A facility might have a main distribution panel, abbreviated MDP, receiving two Y-connected three-phase secondary feeds from three single-phase transformers for several reasons. Firstly, redundancy and reliability are key factors. Having two separate transformer banks provides redundancy in case of failure of one transformer. This ensures continuity of power supply to the facility. If one transformer fails, the load can be transferred to the other transformer without interruption of service. Secondly, balancing the load is another important consideration. The two Y-connected secondary feeds can be used to balance the load in the incoming power supply. By dividing the load across two transformers, the current draw on each transformer is reduced, improving efficiency and lifespan. The current draw on each transformer is reduced by dividing the load across two transformers. Thirdly, voltage regulation plays a role. The use of multiple transformers allows for better voltage regulation. If the load in the facility fluctuates, the transformers can adjust their voltage output to maintain a stable voltage level to the MDP. Fourthly, phased expansion might be the reason. The design may have been implemented to allow for future expansion of the facility. By having two transformer banks in place, it is easier to add additional load without overloading the existing transformer. Fifthly, power quality is a significant factor. Multiple transformer banks can help improve power quality by reducing harmonics and voltage fluctuations. This can be beneficial for sensitive equipment or processes within the facility. Sixthly, cost optimization can be a factor. Using three single-phase transformers instead of a single three-phase transformer bank can sometimes be more cost-effective. Single-phase transformers are typically smaller and less expensive than three-phase transformers. Understanding these reasons is very important for a smooth transition, especially in case of upgrades or repairs. The electrical engineer must take into account all these points. It is important to note that the specific reasons for this design may vary depending on the facility's needs and constraints. An electrical engineer or facility manager should be able to provide further details on the rationale behind this configuration. The advantage of using multiple single-phase transformers for redundancy is that if one transformer fails, the remaining transformers can continue to supply power, albeit at a reduced capacity. This is particularly important in critical facilities where even a brief interruption of power can have significant consequences. For example, in a hospital, a power outage can disrupt life support systems and other critical medical equipment. The two transformer feeds allow for the load to be more evenly distributed, which can reduce the risk of overloading any one transformer. This is particularly important in facilities with large or variable loads, such as manufacturing plants or data centers. The two transformer feeds improve the overall power quality by reducing voltage fluctuations and harmonics. Voltage fluctuations can damage sensitive electronic equipment, while harmonics can cause overheating and other problems. The two transformer feeds provide a higher level of reliability and power quality than a single transformer feed. This can be particularly important in critical facilities where even a brief interruption of power can have significant consequences. The advantages of using multiple single-phase transformers include cost-effectiveness, redundancy, ease of maintenance and repair, and flexibility. Single-phase transformers are typically less expensive than three-phase transformers, especially for smaller loads. Redundancy is improved because if one transformer fails, the other transformers can continue to supply power, although at a reduced capacity. Single-phase transformers are easier to maintain and repair than three-phase transformers. The use of multiple single-phase transformers provides flexibility in terms of load balancing and future expansion. The disadvantages of using multiple single-phase transformers include increased space requirements, high installation costs, and increased complexity. Multiple single-phase transformers require more space than a single three-phase transformer. Installation costs are higher because multiple transformers need to be installed and wired. The use of multiple single-phase transformers can increase the complexity of the electrical system, making it more difficult to troubleshoot and maintain. When designing a power distribution system, it is important to consider the advantages and disadvantages of using multiple single-phase transformers versus a single three-phase transformer. The best option depends on the specific needs of the application. The facility can expand without significantly upgrading the power distribution system by utilizing the second transformer bank. This is particularly useful for businesses that are experiencing rapid growth and need to add new equipment or machinery. The transformers help to filter out harmonics and other types of electrical noise, which can improve the performance of sensitive equipment and reduce the risk of damage. In some cases, using multiple single-phase transformers can be more cost-effective than using a single three-phase transformer, especially for smaller loads. Single-phase transformers are typically less expensive and easier to install than three-phase transformers. The two transformer feeds create a more reliable power source. This is especially important in industries where power outages can be costly or even dangerous, such as healthcare or manufacturing. The two transformer feeds allow for better voltage regulation, which can prevent damage to sensitive electronic equipment. The facility can easily add additional load without overloading the existing transformer by having two transformer banks in place. Harmonics can cause equipment to overheat and fail prematurely, and voltage fluctuations can cause equipment to malfunction or shut down. The dual transformer setup mitigates these issues, leading to longer equipment life and reduced downtime. The decision to use two transformer feeds instead of one is often based on a combination of factors, including the facility's power requirements, budget, and future growth plans. There are several factors to consider when deciding whether to use a single three-phase transformer or multiple single-phase transformers. The total load that the facility requires is a primary consideration, including its present and future loads. Single-phase transformers are generally less expensive than three-phase transformers for smaller loads. Therefore, if the total load is relatively small, it may be more cost-effective to use multiple single-phase transformers. If the load is expected to increase significantly in the future, it may be more cost-effective to use a single three-phase transformer that can handle the increased load. The available space for the transformer is also a factor. Multiple single-phase transformers will require more space than a single three-phase transformer. Therefore, if space is limited, it may be necessary to use a single three-phase transformer. The level of redundancy required is another factor. If redundancy is a major concern, then using multiple single-phase transformers may be a better option, as the remaining transformers can continue to supply power if one transformer fails. The complexity of the electrical system is also a consideration. Multiple single-phase transformers will make the electrical system more complex, which can make it more difficult to troubleshoot and maintain. It is important to consult with a qualified electrical engineer to determine the best option for the specific application. Using multiple single-phase transformers can sometimes be more cost-effective than using a single three-phase transformer, especially for smaller loads. The specific reasons for this design may vary depending on the facility's needs and constraints, as previously mentioned. Another reason for using two transformer feeds into one MDP is to provide a more reliable power supply. If one transformer fails, the other transformer can continue to supply power to the MDP. This is important for critical facilities where even a brief interruption of power can cause significant problems. An additional reason is to improve power quality. Multiple transformer banks can help to reduce voltage fluctuations and harmonics in the power supply. This is beneficial for sensitive equipment that is connected to the MDP. The design allows for future expansion of the facility. By having two transformer banks in place, it is easier to add additional load to the MDP without overloading the existing transformers. The presence of two transformer banks makes it easier to add new equipment or circuits to the MDP without having to worry about exceeding the capacity of the existing transformers. The increased capacity of the two transformer banks provides a buffer against unexpected surges in demand. This can help to prevent power outages and other problems. The two transformer feeds create a more resilient power supply. In the event of a problem with one of the transformer feeds, the other feed can continue to supply power to the MDP. The multiple transformer banks can help to reduce the impact of voltage sags and swells on the power supply. This is important for sensitive equipment that is susceptible to damage from these types of power disturbances. The load can be divided more evenly across the two transformers. This can help to improve the efficiency of the power distribution system and reduce the risk of overloading any one transformer. The maintenance can be performed on one transformer bank while the other transformer bank continues to supply power to the MDP. This can help to minimize downtime and disruptions to the facility's operations. The two transformer feeds provide a higher level of security. In the event of a security breach, the two transformer feeds can provide a backup power supply. The multiple transformer banks can help to reduce the risk of fire or other hazards. This is because the load is divided more evenly across the transformers, which reduces the risk of overheating. It is important to consider the specific needs of the facility when deciding whether to use two transformer feeds into one MDP. There are a number of factors to consider, such as the size of the facility, the type of equipment that is being powered, and the level of reliability that is required. Ultimately, the best decision depends on the specific circumstances. An electrical engineer or facility manager should be able to provide further details on the rationale behind this configuration. The incoming power from the utility company is split into two separate feeds, each of which is connected to one of the transformer banks. The two transformer banks then step down the voltage to the required level and supply power to the MDP. The MDP distributes the power to the various loads within the facility. The two transformer feeds provide a redundant power supply, improve power quality, allow for future expansion, and provide a high level of security. These are all important considerations for critical facilities. The specific reasons for using two transformer feeds into one MDP can vary depending on the facility's needs and constraints. This configuration may be implemented to allow for the addition of new equipment or circuits to the MDP without exceeding the capacity of the existing transformers, allowing easy expansion of the facility. The increased capacity of the two transformer banks can provide a buffer against unexpected surges in demand, which prevents power outages and other problems. The two transformer feeds create a more resilient power supply, as in the event of a problem with one of the transformer feeds, the other feed can continue to supply power to the MDP. The multiple transformer banks can help to reduce the impact of voltage sags and swells on the power supply, which is especially crucial for sensitive equipment susceptible to damage from these types of power disturbances. The load can be divided more evenly across the two transformers, improving the efficiency of the power distribution system and reducing the risk of overloading any one transformer. Maintenance can be performed on one transformer bank while the other transformer bank continues to supply power to the MDP, minimizing downtime and disruptions to the facility's operations. The two transformer feeds provide a higher level of security, offering a backup power supply in the event of a security breach. The multiple transformer banks can help to reduce the risk of fire or other hazards, as the load is divided more evenly across the transformers, reducing the risk of overheating. These factors make the use of two transformer feeds into one MDP a practical and beneficial solution for a variety of facilities.